5 minutes. We will start for today course. I will prepare for YouTube live first this week. Oke, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Please turn on your camera. I want to see you guys.
One moment, yeah.
Okay. Okay, how many students from UM join in this summer school of physics?
15.
15. So you will meet new lecturer every week. So maybe all of lecture will ask you how many student and which department. All of from physics.
Yes. All of us.
Okay. In the third year or fourth year?
Most of us from third year, and some of us are from second year.
Okay.
Yeah.
Okay, nice to meet you guys. Okay, today I would like to tell you about one topic, and this is not common in the physics because I'm from physics, but my how to say I my PhD under chemical engineering, so it's like a chemical engineering and the physics collaboration. So today topic it's not common, I think, in the physics course, but you can get more information about the today course or about the membrane technology. So still waiting all students join in this meeting. So don't forget to fill attendance presence in the comment below. The link I put in the comment below. Then I will okay, I will share screen now. Then we already live in the YouTube. So if you want to replay for today course, you can play from the YouTube channel and the Fisika Universitas Indonesia. So I hope I can see you in the UI soon, so we can go around UI or we can explore Indonesia more. So yeah. So today topic is about basic principle of the membrane technology. Okay, guys. So for the reading list, recommend maybe for because this summer school is just short, so no need to download for this book, but I just want to give you a recommendation book for membrane technology knowledge, so you can see from this book. I want to reminder first for the student who not feeling the pretest for the summer school in the physics. I just got 12 students who already who already give the answer for the pretest. So who already uh, join in this pretest, or you don't know about the pretest?
Yeah, we join most of it.
Yeah, most of you should enter should the sign in the an e-learning management system UI and must do. Maybe you can see now. So you do you have a SSO account ID? Did you get it?
Yeah, yes.
Yes, we have.
Okay. Yeah, yeah. You just only enter there and you sign in there, and then you can choose the how to say the course. It's Capita Selecta 2. Then you can choose the pretest summer school there, and you can fill it here because this pretest for your grade and for your how to say is for your grade and for our record that you join in the summer school in the physics 2023. So if you guys don't know about that, maybe after this course we can I will help you how to enter and how to fill the pre-test summer school. Okay, wait a minute. I have okay because it's just only 12 students that uh, I get this data. Okay, maybe before our course you can it's not okay. You can scan this one, the multi meter uh, data. I want to know you uh, how much do you know about the membrane technology? I will. Do you have phone, right? I want to make this course is more interactive, so maybe you can scan it now. Okay, I will check here. Still waiting for the response. Just give me one word that you know about the membrane technology. Membrane molecule, fuel cell application, proton exchange membrane, good. Nuclear membrane, good. Diffusions, good. Biology, yes. because many people know that membrane is the biological osmosis, yes, diffusion, osmosis. Thin, yeah, of course, thin, good. So, now, nanofiltration membrane maybe. Electrodialysis, yeah, in the physics, electrodialysis, microfiltration, yeah, good. Barrier, yeah, from gases, consider thickness, yeah, good. We should to know about the thickness of the membrane separation, yeah, good. So, okay, most of you I think know about the membrane technology, but maybe we should to more clearly understand about the membrane technology. Okay, and I will start this course today. Okay, today course content is about the fundamental of the membrane. How should to minimize this one first. The fundamental of the membrane technology. The second is the membrane separation technique, because in the physics, we not just only separate the molecule, but also we create energy from the membrane. So we will discuss about the mechanism of the membrane technology and membrane filtration process. Maybe for the today, it's not more discussions about the membrane filtration process, but I will show you one by one in the next day. So the third is the types of the membrane structure and configurations. Because as we know that membrane, it's not just only a flat membrane, but we have a lot of the uh, kind of the membrane. So we will discuss about the synthetic membrane materials and membrane configuration filter types. So the learning outcome is the student can understand the definitions and applications of the membrane, because I forget to introduce myself. My name is Januar, and I'm from Department of Physics, in the physics material especially. So if you guys in the material physics department, so you will facing about the materials, and then one of the material is the membrane, so something like this. So now it's the learning outcome is the student can understand definitions and application of the membrane. And the second one is the student can distinguish the structure of the membrane. The third one is the student can understand the mechanism of the membrane separations. And the last, student can distinguish filler types of the membrane and the fundamental of the membrane technology. So today, we are facing a lot of problems, such as the global warming issues. The environmental problem that can be solved using membrane is the membrane technology is the one of the technology can solving that problem. For example, the climate change, extreme weather, and at all is the one of the problems that make a global warming issues now. Then industrial is the one of the technology that give many problems or give the negative how to say it's disadvantage for the our environmental. So we are know that industry give us like carbon dioxide gas or SO2 gas or everything that pollutions that they giving to this environmental, and they give also like how to say it's like dye pollutions for the water. So it's like giving our damage for the water, and like we are difficult to get the clean water for our consumptions. It's like if we want to drink, now it's heavy metal pollutions and dye solutions in the water and everything, and not just only in the water, and the pollutions in the air also. So the industry is the one of the in how to say how one of the problems technology that give problems in our environmental. So membrane is the one of the technology that can facing this problem, this or solving this problem, like industrial wastewater, microfiltrations. One student knows about the microfiltrations, uh, uh, and ultrafiltration, nanofiltration, reverse osmosis, water desalinations, and at all. So the membrane technology is the technology can solve that problem, like global warming issues, for example, in the carbon dioxide gas. So the membrane technology can absorb the carbon dioxides in environmental, in the air pollutions. And for the water desalinations, also the membrane can separate the heavy metals or dye pollutions in the water. Then they can separate dye or heavy metal to get the clean water that we can consume. All of the problems, this is the one the sustainable development goal that we want to solving. Then as we know that definitions of the membrane technology, I think most of all the student knows about what is the membrane. It's like biological. It's, for example, it's like your skin. You can separate, or you can select that molecule that you want to get. For example, it's we will see from the definition first. A membrane technology is the selective barrier. So it's like thin barrier. It allows something to pass through but stop others. So if you want to consume clean water, so we want to reject the pollution from the water. It's like heavy metal, salt, or dye. If you want to get clean air, so we want to stop the molecule, or we want to absorb the molecule, and we can convert to another energy. So we can use the membrane. And the membrane separation process is the process where a membrane is used to separate the component in a solution by rejecting unwanted substances and allowing to others to pass through the membrane. So if you want to get the clean water, for example, so we want to reject another molecule, not just on not the clean water one. And next, membrane are used the wide energy of application. So not just only for the cleaning gas or the cleaning water, but membrane also can create energy. In the physics, we call it the piezoelectric membrane. So I will show you later. Here, the classifications of the membrane. So membrane for the material physics, we will see so many material that we can use, such as the organic one, organic materials, inorganic materials. So we use also in the membrane technology here. So like a polymer, macromolecules. So we can choose also dense polymer like PVDF or at all. Then we can use also inorganic like metallic, ceramics, and glass. So different material, different functions. And the configurations of the membrane, as I say before, that membrane is not just only flat, but also hollow fiber, capillary, and tubular. Structure of the membrane is the symmetric and asymmetric. We will discuss later. And types of the membrane also hydrophobic and hydrophilic and charge ion exchange. One of the students know about this one also. I think already types in the Mentimeters, so like ion exchange, diffusions, and everything. And for the hydrophobic, it's depend for the types of the support of the membrane. It depend of the applications. Like hydrophobics, most of them use for gas separations. In the hydrophilics, most of them use for the water separations because they like water. So hydrophilic. So it's depend on the applications of the membrane. Industrial membranes, we will see from driven process and reactor. So it's like reverse osmosis. It's depend on the pressure, temperature, electrical potentials, and concentrations such as dialysis, osmosis, and extractions. And for the reactor, it's the catalytic membrane, bed catalytic membrane, and et al. So the membrane, it's that's as say before, the membrane technology is not only for separations, but in here, the technology of the membrane can also create some energy, such as, for example, in my research, I use graphene and PVDF. It's something unique because it has uh, piezoelectric properties, so they can create how to say energy. It's like voltage, and if you touch the materials with the pressures, they can give the electron excitations, so the electron can move from uh, positive side to negative side, or uh, negative side to positive side, and then they can create the energy that give us like output voltage in the membrane. For example, also the membrane technology we can put in the t-shirt or in our outfit, then they can give the energy or give the voltage from this one. And the membrane separation technology, we can separate from the four kind of the separation process. First is the microfiltration. Second, it's the ultrafiltrations. Third is the nanofiltrations, and the last one is the reverse osmosis. Why we separate for the four kind of the separation technology? Because it's depend on the molecule diameter or molecule size. If we use the microfiltration, so we just only can separate or we can reject more than 0.01 micron. So we can reject suspend particle, oil, macromolecule, and et al. We can see from this side. Then for the ultrafiltrations, we can the membrane should have the pore size between 0.05 to 0.01 micron. So it's more small. It's smaller than microfiltration. So they can reject virus and protein, and then also monovalent ions. And next one is nanofiltration. It's the common of the technology for the membrane technology, like salt rejection, heavy metal, ion rejections, and dye rejections, they always use nanofiltrations for this process. Nanofiltrations can reject monovalent ions, divalent ions. So it's depend on the size of the molecule that we want to separate. So in this nanofiltration, we should to have the pore size between 0.01 to 0.005 micron. And next one is reverse osmosis, is the smaller one than all the process separation technology. They can just only reject monovalent ion, and yeah, it's more selective and more sensitive. Here is the process of the membrane. We will discuss later. The membrane separation technique. As I say before that microfiltration, ultrafiltration, nanofiltration, and reverse osmosis depend on the size or pore size molecule. So microfiltrations is the liquid or gas we can use for applications such as liquid and gas. For example, is like protein separation, juice clarifications, heavy metal removal, and et al. For the juice clarification, I think food industry use it. And ultrafiltrations we use for like treatment of the food also, beverage industry, and useful for the material from the coating or dyeing that or automotive and textile industry. And nanofiltrations, I say you before that we can use for the salt rejection, dye rejection, and et al. Here, another functions or another separation technique is the electric dialysis, such as sea water desalination, electrical potential gradient, so ion exchange here, and gas separations and pervaporations. Gas separations, we can capture the carbon dioxide and change the carbon dioxide become the energy. It's like biogas, how to say? It's like yeah, it's gas um gas capture, and in the pervaporations we can how to say make pure like pure alcohol, ethanol, and et al. So it's like if you want to get the 100 pure alcohol or ethanol, you can use pervaporations separation technology in the membrane technology. From this, have any questions from the student?
So far, no, doctor.
Okay, if you have any question, we can discuss directly, and then I can move to another slide. So now, membrane for different separation technique. As we know before that many we have four technique, or I think we adding three more technique, right? So we calculate like we have 7 technique for the membrane technology, and then the technology for the separation technique depends on the molecule size that we want to separate. So the particle, for example, here the particle size it's 1 Armstrong, 10 Armstrong, and 100 Armstrong, and more than that. So it's like a carbon dioxide. We use the gas separation membrane technology in this area, and most of them use a non-porous membrane. So we can see the structure of the membrane. What is the non-porous membrane? What is the porous membrane? So as I say that carbon dioxide, nitrogen, oxygen, hydrogen, and everything for the gas molecule, they use the gas separation membrane, and they use non-porous membrane. For the how to say, pesticide, herbicide, and everything, we use the reverse osmosis, dialysis, or ion exchange. We can also use the non-porous membrane here, and we can use also microporous membrane. So it's depend on the size of the molecule. Like virus also, we use the ultrafiltrations because it's more than reverse osmosis, right? And then for the colloidal silica, we use microfiltrations, and the bacteria also we can use microfiltrations. So all of this, it depend on the particle size. Right. Nah, this one is the you can imagine that this is a heavy metal ion, and this one is the water. So if we want to get clean water, we can use the membrane for separation process, and the heavy metal we can reject. And there are definitions of the some of the definition in the membrane technology. Some first is the feed. Feed is the solution that that we give or we want to separate in using the membrane. So feed it's the from the left side or the upper side. So it's depend on the technology. And retinate. Retinate is the molecule that we can reject. It's the how to say, it's the molecule that we don't want to use it. Permeate site is the molecule or the liquid that we want to get it, and driving force is the force for the membrane. So we have definition feed, permeate flux. So we need to calculate how much the flux for the membrane. If the membrane have a good flux and have a good selectivity, so we have the good performance of the membrane. So the key of the membrane is the flux and the selectivity, permeability or selectivity. Here, the membrane filtration process. There are two filtration process. First is dead end filtration. Dead end filtrations is if you have a feed and then you give a feed from the upside here, then you press the feed to the membrane. So you use the dead end filtration. For example, if you have the water and then you press it using the pressure filtration from the upper side, or you give like 2 bar of the gas to press the membrane, so you use dead end filtrations. But another one is the cross flow filtrations. These cross flow filtrations, it's the common how to say, common technology for the industrial applications. Why? Because of the industry want to have the long terms stability of the membrane, and then they want to have the membrane have a lifetime, a long lifetime of the membrane. So they choose to use the cross flow filtration. They give feed from the left side to the right side, then they can separate the molecule, but it's not high selectivity or high flux because they give a pressure from the left side or right side, and they not pressure from the upside, but they can maintain or they can get the maintain the stability of the membrane, or membrane can not easily to broken, no break. So in here, if we give the much pressure or like 1 bar, 2 bar, and then more than 2 bar, the membrane will easy to broken or break. Then if we use the cross flow filtrations, the membrane will still stable in that area. So that's why industry more like use this technology than this one, than that infiltrations. But in for the student, if they want to use for heavy metal or dye rejections at the right time or at the phase time, so they can use that infiltrations in the just only laboratory um, technology. Here, the basic requirement of the membrane performance. So we should have high permeability of the membrane. What the permeability? As we know that permeability is the component to be separate. So if you have like here is the carbon dioxide and the hydrogen mixture, we want to get the hydrogen uh, purifications or pure hydrogen gas. So how much the gas that can pass through from the membrane process, and we can calculate the permeability. So if we get a lot of the hydrogen gas in this site, in the permeate site, and when we calculate the flux, then permeability is high, so we can uh, get the good permeability and good selectivity of the membrane. And then the basic requirement, we need to have a low effective membrane. So if we have a low thickness of the membrane, low or effective thickness of the membrane, so we get the good how to say good efficient of the membrane. So the researcher know they want to create as so much or so thin of the membrane. It's not too big, so not it's a thick the thin of the membrane, and then they can selective to the material, so easily to how to say to save it, and then easily uh, to maintain it. And then the membrane should have also good mechanical strength, because if we give the pressure of give to force on everything, so membrane is not easily to break. Then membrane also should have high stability in the real working conditions, because membrane is not the lab scale only, but also we used in the industry scale. So membrane should have the stability and in the working conditions. Here it's depend on the molecule that we want to separate. We can separate just only just hydrogen. We also can separate only carbon dioxide. So depend on the pore size or the material in the membrane that we use. Here, for the permeability and the selectivity, it depends on the material also. For the inorganic membrane, it mostly they have like a low permeability, but it's the middle selectivity. Better selectivity than the polymeric membrane. But in the polymeric membrane or organic membrane, the permeability it's good, but the selectivity it's low. But nowadays, the researcher use mixed matrix membrane. Or what is the mixed matrix membrane? It's the membrane that how to say mix the organic materials with on organic materials together, and they create a mixed matrix membrane, and they have good selectivity performance and a good permeability performance. From here, any questions? Okay.
I do have one question.
Okay.
Do inorganic or polymeric membranes, do they degrade over time with use? And if so, how are they like replaced?
Okay. Can you repeat habits for the questions?
Uh,
Degraded.
yeah, do they degrade over time, membranes with usage? And if
Yes.
so, how are they replaced? Yeah.
Okay. You mean like for the organic or polymeric or mixed matrix habits?
I wanted to know for both actually, or all of them, because I'm not sure if synthesized or uh, only organic membranes degrade. I'm not sure which one. Or
Okay. Actually, for the grade, I think we how to say all of the like in organics or organic membrane is we should to synthesize first for the no the material we can use directly to the membrane, so it's like we casting the membrane the materials the process, and then it's not the I think it's not degrade for the materials, and then for example, for inorganic membrane materials, it's from inorganic, right? And then they don't have like a good how to say they will give low pore size, and then we should to have a good or match pore size in the membrane, and then we adding some of the organic materials in the membrane, and then we can how to say we can make a membrane it's different properties, and then we can mix the properties from the inorganic materials, and then we can mix also from organic materials. So maybe I should to show you how to say show you the applications of the membrane material with the difference of the materials such as inorganic and organic, because it's more confused in if you only see from this figure. I will share you later.
okay. I was just wondering because I wasn't sure if if over a long period of time, let's say in a reverse osmosis process where they're
Mhm.
filtering water, then do they have to, what happens to the membrane? Does it actually stay the same, the pore size and everything? Does it
No,
like,
it
yeah.
no. That's why we all of the researcher want to have the long lifetime of the membrane. That's why we want to have the stable good stability of the membrane. So if we for example, if we want have one material and we use again every times, and we just the membrane uh, will break or broken, and then the membrane will have a different pore size from the first one. So that's why most of the researcher want to create the membrane have a stability of the properties, and then they like mixing one material to another material to get the good stability and good mechanical strength of the membrane. So that's why habits you are correct that membrane it's not how to say they still have like a lifetime, not stable every time, like just only 1 year or 2 years. It depends on the materials, but the industry they mostly use it like they can change the membrane to, for example, for the water or heavy metal rejections, they use like 2 years, and then they should replace the for the new membrane. Or they can adding some of the material that can how to say, make a good stability of the membrane or good properties of the membrane. And habits, sometimes the membrane also have the facing that how to say, antibacterials how to say, damage also for the membrane. And then they adding some material that can how to say, help the membrane to make bacterials die in the membrane. So yeah, its membrane, it's not stable for the long time. So
Okay,
Habits,
thank you. Yeah,
do you have more questions about
I know
that?
that's all from me.
I will show you later. Maybe for the how to say, membrane technology applications or research, they always measure for the stability of the membrane in the last part, because it's the key of the part that we should to know that how long membrane can stable and how long the membrane can use and use again in the some of our applications. So yeah, it's the key. Then I will continue for my presentation. Wait, so hard to. Okay, next. It's not working. Okay. Here for the calculations of the performance, uh, membrane, we should to know how much the flux, permeability, and the selectivity. And then as we know that flux, we can calculate from the feed side and the permeate side here. And then per, how to say, the membrane thickness. So how much the membrane thickness here, and then how much the uh, pressure or the permeability from the upstream pressure and then downstream pressure. And then permeability also we can calculate from diffusions of the membrane, and then the solubility of the membrane. They will show the solubility and diffusions in the measurement instrument, and they you just can easily to calculate how much the permeability. And the selectivity is the permeability of, like for example, this one is the carbon dioxide, for example, this one is the hydrogen. So how much the carbon dioxide can separate between carbon dioxide and hydrogen. So it's like this. It's like you can calculate the selectivity from the mobility of selectivity or the solubility of selectivity. It's depend. You can calculate also from the permeability of the selectivity. So it's just how much selective your membrane can separate that molecule. So the types of the membrane structure, you can see here the types of the membrane structure and the configurations. For the non-porous membrane, like ion exchange and everything, I think they they mostly use it in the non-porous membrane, because they can use the diffusion phenomena in this membrane. So, like for example, they want to reject the positive charge of the molecule, and they just want to get the negative charge of the molecule. So in the membrane also can use how to say, can make it, because as in the membrane technology, they can calculate how much the charge of the in the membrane, and then they more positive or they more negative. We can call its Donan efficiency in the, or Donan effect in the membrane process, diffusion process. Donan efficiency means that, like, if you have a more positive of the membrane in the membrane. So you can reject the positive molecule, like positive and positive. It's not how to say, it's not interact, right? Like repulsions. So uh, if you have like molecule of dye, for example, it's methylene blue, it's positive charge, and then your membrane is the graphene, it's negative charge. So they will interact, and then the positive and negative charge the negative charge can easily to the positive can easily to pass through, and the negative charge is the repulsions or reject of the membrane. So it depends on how much the charge of the membrane that you have. They always measure using how to say, I forget the instrument name, but they can know that how much charge in the membrane. And then the porous membrane, it's like here molecular sieving, molecular sieving membrane. It's technology that you should to know how much the molecule size and then how much the pore size of the membrane. So if the molecule and then the pore size of the membrane it's matched, so the membrane the molecule can easily to pass through of the membrane. For example, it's the carbon dioxide. It's 3.2 Armstrong, or yeah, it's like how much the molecule size that we have, then the pore size should be matched with the molecule that we want to separate. And the affinity effect, it's something same with the diffusions, but they have how to say, it's pore size in here, and the pore size should have charge more positive in this side, so the negative side will be easily to pass through. That's it's similar with the solution diffusion model, but in here it's non-porous, but in here it's the porous. In the porous, they will how to say, interact with the positive and negative charge in here. Johnson diffusions model, it's the how to say, in diffusions, but using pore size, and then using the big pore size in this phenomena, and then the how to say, the molecule will easily to pass through, and then in here the nonsense diffusions is the how to say, good permeability, but it's the low selectivity, because all of molecule can easily to pass through, and then we cannot separate or cannot distinguish which molecule can separate. And the convective flow. The convective flow, it's similar with the condensation diffusions, but it's more bigger, and then the molecule or particle can easily to touch in this side. And I will wait. This is okay. The synthetic material can be classified in the selective barrier. So we always have the selective barrier and structure and the morphology, and then membrane materials. As we know before, that membrane material like organic and inorganic. So it depends on the application and depend on the properties of the material that we can use. And the selective barrier, it's non-porous, is here, non-porous membrane. Pore size diameter is less than 1 nanometer. So if you're facing that membrane have the 1 nano more or less than 1 nanometer, we can call that it's non-porous membrane. And if the porous membrane, it's mean that more size diameter is 5,000 or 100 nanometer. This is micro. Different force of pressure gradient. Okay, then next. Here, for example, it's the graphene. You know that, right? Graphene is like honeycomb, or graphene it's like how to say, it's hexagonal structure of the carbon. So if we have the laminar of the graphene, we can see like graphene, we put together, or we feel that graphene have the stacking layer between each other. So the molecule can separate in here in this site between each graphene. So I use graphene for the carbon dioxide, for example. So the carbon dioxide can easily pass through, but the nitrogen or oxygen can difficult to pass through up to the membrane. So I can get the carbon dioxide molecule here, and then the oxygen and nitrogen can easily to separate from that side. And then sometimes they use graphene oxide. They break this side to make a bigger pore size, and then the pore size can match with the molecule, and then yeah, they can easily to make a one thin layer of the graphene, and then can separate the molecule, yeah, for example the carbon dioxide. This is 2D material of the membrane. And the types of the membrane structure, because as we know that membrane is just only, how to say, it's like pore size, but we have the so much, how to say, different types of the structure of the membrane. For example, this symmetric structure. This is the cylindrical process, pore size. I mean, the cylindrical. They create the membrane and have the cylinder pore size like here, or porous web or sponge membrane. Sponge membrane is like here, or dense polymer film. So if you facing dense, porous, and cylinder pores, we can call the symmetric. Symmetric means that all of the pore size is the similar or homogeneous. For the second one is the asymmetric. Asymmetric membrane is like different types of the pore size in the inside of the membrane. So in the top side, the selective layer, we can see here it's more, how to say, more dense or more small of the pore size. But in the bottom side is the pore size is bigger than the top side. So we can call asymmetric membrane. And then as we know that the asymmetric membrane is the thin porous or non-porous selective barrier support mechanical by much thicker porous substrate. So we can call also the asymmetric membrane, it's an isotropic membrane. For the symmetric membrane is the isotropic membrane. So isotropic membrane you can use for the microfiltration, gas separation, and et al. Or ion exchange is the symmetrical. So if you're facing that isotropic structure, so isotropic structure means that symmetric or have a similar pore size or have a dense polymer membrane. And composite membrane, it's the last one is the composite membrane. Composite membrane means that membrane have a different of the pore size or different of the materials inside of the membrane, like symmetric or asymmetric structure mixing together in the one of the component of the membrane. Here is the types of the membrane structures. Here symmetric is like dense membrane, dense top layer membrane, and porous substrate. And the composite membrane, we can see top selective skin. They should to have selective layer here and porous support and the mechanical support layer. So they not just only have one thin layer, but they mixing with the layer by layer, have the selective, porous, and the mechanical strengths. Here the composite from the surface electron micro. This is the structure of the, how to say, the structures of the membrane from the morphology of the membrane. This is composite. It's the top layer, intermediate layer, and the support layer. This is dense. Dense, you can see the dense membrane. There is no porous here. And the asymmetric is the this is have the dense selective layer, and then this is more bigger porous layer or a membrane. And the symmetric in organic membrane, it's the porosity, it's similar or the homogeneous here. And the summary of the structure is isotropic. We can see here the microporous, the membrane in the isotropic, or we can call symmetric membrane. We can calculate also the charge of the membrane here. And then the anisotropic, we can see like TiO2 membrane. If you working on, how to say, I forget the photocatalytic materials. You can also combine with the membrane technology. Like you can put like TiO2 is the one of the material for photocatalysis properties, right? Then you can mixing TiO2 in the membrane polymer, and you can put the membrane in the surface of the, how to say, dye water or in the salt water, and then you can create energy, or you can get the how to say, you can get the pure water, and you can see the phenomena of the photocatalytic in the membrane. Here is the composite membrane. You can see the thin selective top layer and thick height and et al. So from that membrane, I will show you for the applications and the paper reference in the next day. But now, as we know that we already know that what is the definitions of the membrane, and then what is the structures of the membrane. And then here is the material that commonly used for the membrane technology, like here in organic polymer membrane such as cellulose, PTFE, PVDF, and et al. In the PVDF, they use for the piezoelectric membrane. If you want to create some voltage or energy, you can use PVDF in here. And in the organic, it have the properties such as the rigid in the glassy form or flexible in the rubbery state, cost-effective, good, selective, and easy process, and falling chemically non-resistant and limited operating and short lifetime. And in organic, we have like ceramic, metallic, and carbon. If you want to use for the photocatalytic, you can use the metallic membranes or ceramic membrane. I mean like TiO2 and et al. In the membrane, and you can mix together in the polymer, and then you can easily casting, and then make it to the for the membrane process. And here in the industry, they always using a hollow fiber membrane. Membrane is not only flat like this, but also they can create like hollow fiber of the membrane. It's more easy to clean up because if you just only shaking the membrane, and then the bacteria or everything, the pollutions can easily to how to say degrade it, or easily to clean in this polymer of the membrane. And then the tubular membrane, it's bigger than the hollow fiber membrane. It's for like water separations. I mean, maybe in the industrial, they want to cleaning the pollutions or the waste water, and they use tubular. And we can see here the cross sections of the membrane from SEM, surface morphology. here the porous and then the one is this dense and this one is double layer. So if you have like water and then the water can dialysis or they can separate from the side and then because of the pore size they can keep the pollution can keep inside and then yeah it depends on the applications and if you want to clean just shaking this membrane and then they can reuse again for the next terms. So yeah, you can use it like and then it's more stable if you make a membrane to be fiber, better than just only how to say flat membrane. And the flat sheet membrane have like here and the configurations and advantage and disadvantage of every each membrane configurations. We use the flat sheets process high solid loading easy detection but low packing density because of the flat. If we use tubular, they have this advantage like low membrane density and high energy consumption. If we use the spiral, yeah, we have the high packing density, but dead end are difficult to clean because it's too small. And if we use hollow fiber, we have the high packing density, but pre-treatment requirement easy leakage and difficult to detect membrane defect. It's depend on the application. Or any questions, I will summary this meeting. For membrane is the selective barrier. It allows something to pass through but stop others. And the applications, we have microfiltration, ultrafiltration, nanofiltration, and reverse osmosis, and electrical dialysis, gas separation, and pervaporation. And the structure we have dense, symmetric, asymmetric, and composite. And mechanism is like diffusions, molecular sieving, affinity effect, Nansen diffusions, and convective flow. And the types of the membrane is the hollow fiber membrane, spiral wood, tubular membrane, and the flat membrane. Thank you. Any questions? We can discuss more, and then if you guys didn't fill the pre-test, I will waiting until this meeting end, and then maybe you can fill the pre-test first now because some of the lecture want to see how much understand are you for this summer course how to say summer course sessions, and then how much you understand before you start the class for the some of the courses. Okay, any question for the membrane technology? Next meeting, I will show you some of the paper and we will discuss about like diffusions, gas separation technology, and piezoelectric properties because as we know that we are physics and we want to know that membrane not just only separate but also membrane can create energy and I make like a membrane and then we can create energy also can separate the salt water and then I can saving the energy from the membrane and I put in the battery to how to say to make energy to turn on the light or turn on the lamp. Then yeah, membrane is not just only separations in the physics. You have
I do
any
have
question?
one question, if I
Mm-hmm.
can. So
Who asks?
in
Oh, Hafiz.
yeah,
Okay, Hafiz.
yeah. Um, in from what I can see, so filtration usually happens with either liquids or gases.
Mm-hmm.
But what if you were to move to like ionized gases like plasma? Can plasma be filtered or not?
Yeah. Some of the okay. When I'm PhD, and then some of my friend use plasma for the separations process also. Then, like iron, right? Habits. Yeah, it's depend on the material that we can use for the iron properties. So it's not just only liquid or gases in the membrane separations, but
Uh,
I did gas and the liquid, but I'm not used for the ion. But some of the paper or some of the researcher use it also. Maybe I will searching for you. You have question more? Are
for
you
me, no. For me, no.
it's you understand or not? Like
Yeah.
yeah, for the membrane, not only gases and liquid, but ion exchange also can use it. Or how to say it's have it's that separator from for battery
Mhm.
in the inside of the battery, if you know that they use a separator, right? Some separator there, and to separate like ion exchange or the like how to say electron. I'm not understand what the process, but some of the researcher that want to create some battery, they come to my office, then they want to use my membrane for the ion exchange membrane like that. Then they use the for the separator of the battery inside of battery, and then yeah, it's working. But I'm not sure what the process inside there, but maybe they want to create how to say they want to just only take the electron or proton, I don't know, but they use it for the ion. Yeah. So it's like that. Uh, is there any question more about the uh, membrane? I will show you in the where is Thursday for the applications of the membrane, and then make you understand about the technology, because in here today I'm not showing the process of the separation, and then maybe you can understand for the process of the separations in next meeting. And don't forget to fill the pretest. Now, we still have time for discussions if you want to discuss more about the membrane or about anything else like material, what we use, or you guys have some experiment and then need membrane for the separation process or for the additional applications or additional experimental or everything, you can ask now. In now it's holiday, or you
Currently it's sem break, I think. Yeah.
summer break
Semester break. Yeah.
or semester break, right? And then you have until August.
I think October is when the new session starts. So then Sem 1, Sem 2. Yeah.
Okay. It's summer. Can we know the test mark? Wait a minute. Shall I? Wait, I will check it first for your test. Still 12 students enter this. Oh, kami sedang libur. Yeah, you can speak bahasa also, right? Why it's just only 17 here? Some of the student not join the class. Oh, don't forget to fill today attendance presence, and then I will, if you cannot enter MS2 in the system, I will how to say, invite you using your email account. So don't forget to fill the email account. But the email account is the new account from UI. You have ui.ic.id, right? In email. Mungkin ketiduran.
Yeah.
Okay, maybe I will stop today class, and then don't forget to tell your friends about your pre-test. Then we will see you Thursday again, and then I hope we can see each other in UI. Then what is it? Wait a minute. Okay, jangan lupa foto. Okay, don't forget to take a picture, and then don't. Can you open your camera for? I want to take a picture first for report today. Then for today class, and I hope your vacations enjoy. Then yeah, I will take a picture first. Then. 1, 2, 3. Good. Wait a minute. Okay. One more. 1, 2, 3. Good. And sum all. There is no women, right? Here. It's all the men. Okay. Habits, thank you for your questions. For all the students, I hope you have question next meeting. We should to discuss more, and then we will. How to say? I hope we can see each other and discuss more. Okay. See you guys. Enjoy your holiday. See you later next
Oke,
Thursday.
bye-bye dokter.
Bye.
Thank you, Dr.
Assalamualaikum.
Waalaikumsalam.